I still remember way back then while I was 14 years old, during one of the science, there is an experiment where you have to play a lot with the powders. You know, you take the powders and then you burn it, and then it gives certain colors, red, blue, yellow, green, and so on. And instead of doing what my teacher said, but I just try to mix up 2 powders, 3 powders, and I mix up all the powders. And when I burn it, it's just like a spark of colors. So that is actually a basis of fireworks. And I think that is one of the moments that spark, the chemistry part in my life. Spark the interest, which is actually all the colors basically fascinate me to do something related to science. So I just like to start briefly about my work, which then I can relate to the young ones, because when you were young, people don't take you seriously. Yeah, so I do believe that. But how to make some changes for the youth, especially who really, they have the interest in science, but they don't know how to pursue science. So I take myself as an example. So when I start, there are many mysteries in life. Yeah, for example, how the star, why it shines brightly, then it leads to all the quantum. I know that one is slightly more requires scientific explanation. But what I would like to tell, when I got fascinated with colors from fireworks, then I can relate that to rainbow. Yeah, because of the prism, there is color. So from there, normally I try to attract all the young ones because science is actually colorful. There are many things to study. And from there, I start to develop my own research. But of course, at the same time, I do have like kind of a mentor. Yeah? So they assist me. And when I can establish on my own most of the work, so I try to get most of the young ones to be part of my work. So I don't really call them like kind of my student or what, but I thought that all my student is actually my teacher because they know better their work rather than me. I have the ideas, but these are the people who implement the works. So there are many bright Malaysians over there. So this is why one of my passion is towards the youth. Either it's from primary school or secondary school or even tertiary. So try to get them to do science, and from there, I have to tackle certain issues so that they stay in science, because that is one of the major challenge. For me to success in science, you need passion, persistence, and of course, ambition. Now, the fireworks actually normally come from metal, so it gives different colors. So now I start to engage from metal catalysis to biocatalysis. It's actually 2 different worlds. I'm a trained chemistry and computer scientist, my PhD in physics, but my research is actually in biotechnology. So it's actually a multidiscipline. Yeah, multidisciplinary, or people also call it interdisciplinary. And this is how as well one of my selling point to get the youth to join me. Why they have to do just physics? Why they should do mathematics? Just mathematics. But you can do mathematical biology where you can study how the protein works. Okay, so that is the part. And then when one of the project that I'm doing right now is something related to Antarctica. So this is interesting. People always say, oh, you are Malaysia, in tropical country, why you do something in Antarctica? But from our study, I managed to get this one protein called antifreeze protein, which is actually being used in the organism or microorganism to sustain, because of the temperature. So they're able to live in that extreme temperature because of this antifreeze protein. For example, we can apply this in ice cream. As we know that ice cream, especially in the tropical country, you have to put in the freezer, take it in and out, in and out. So what will happen, you can see all the ice crystal growing up. okay, and then the taste will not be as good as the moment that you first open it. So what we do is we try to replace the current antifreeze agent, which is normally toxic, yeah, with this antifreeze protein. And using my expertise in computational chemistry, so we try to, instead of using the whole protein, we cut it down. We take one of the fragment, which we believe that this is the most important part, and use it in as the antifreeze peptide. So this is one of the particular things that we should do right now. Yeah, we try to minimize the system, and then it will be easier as well to be applied, less expensive and so on. So we are hoping that, for example, this work can be used in the ice cream, and as well, if we're talking about medical application, might be a cryopreservation for the organ transplant. So, research is actually, there is no shortcut in research, and it is extremely hard, but you should do in smart way. You need teamwork, and the most important is multidisciplinary sciences, or you can call it as one science.